So let's talk about inverse trig functions. So we have already talked about trig functions, as in sine, cosine, and tangent. We've talked about SOHCAHTOA and the sine being the opposite over the hypotenuse, or on the unit circle, the sine value being the y value. So here's an example where we say sine of 30 degrees. The input is 30 degrees, and our y value, of course, is 1/2. So we've already talked about this. If we think about the unit circle, we can think about 30 degrees. We look at the terminal point. The terminal point is √3/2 and 1/2. And so therefore, the sine of this 30 degrees is 1/2. So notice in this case, this is clearly a function, this idea of function, because we have one input and we have one output. The inverse would be saying something different. The inverse would be saying something like the sine of which angle or angles give you 1/2. Right? So it would be sort of answering this question of, here, let's write this down first. So we've done this before, the sine of 30 degrees, and we say, oh, that's 1/2. We could also say something like, well, what's the sine of 150 degrees? Well, that gives me the same exact thing, right? It's 1/2, because the sine of 150 also has a y value of 1/2. So there's my terminal point here, negative √3/2, but positive 1/2 still. So this is true, right? So I've given you these questions before. The sine of 30, the sine of 150, the sine of any angle on the unit circle. Well, the inverse is going to be something like this, where we answer this question. The sine of, which angles, the sine of which theta is going to be 1/2 here, right? The sine of which angles are going to give me 1/2. So then we would start to look at the unit circle, and we'd sort of go around on the points, and we'd kind of do a reverse lookup. We'd be looking at the unit circle and saying, where are my y values 1/2 here? Well, I can see one at 30 degrees, and there's another one at 150 degrees. So there's sort of a dilemma there. And is the answer to this 30 degrees, or is it 150? What do I plug in there for theta? Well, the answer is really, both of them would make that equation true. So we have a little bit of a problem here, because if we think about this question now, and we want to use this notation for this inverse relationship, right? The question that I just asked is, where's the sine 1/2? And there is a lot of different angles that make that true. 30 degrees, 150, and actually any coterminal angle from those 30 and 150 would also make it true. So there's an unlimited number of angles here that would make this equation true right here. Okay? This is the idea, though, is that we have normal trig functions which take in an angle and give us an output, right? Opposite over hypotenuse in this case, or the y value. The inverse is saying the sine of which angles are 1/2. And if there are many outputs to each input, then we can't really think of this as a function, because a function is 1-to-1, right? So we're going to start talking about in the next videos of how do we treat this like a function. Okay, this is the notation that I'm going to use. Sine inverse, the inverse sine of 1/2, and what does that equal, right? We're going to learn that it equals just 30 degrees, right? We all have to agree upon some sort of rules that, so this function is going to give us exactly one output, and it's always going to be the same output. If I put sine inverse of 1/2, it's always going to give me 30 degrees. So the question you might have is, well, you know, if I plug this into my calculator, yeah, I see that it gives me 30 degrees, but why not 150? Because 150 is also true in that case. So those are the questions we're going to be talking about. This is the same case for the cosine function and the tangent function.